Okay, here we go. We are going to get ready for the context part of our test. Our context part is going to be on Delta Math, and that's what we're going to practice. So these are the four different types you're going to see on your test. The first type is going to look like this. So he's taking a multiple choice test. The linear graph below represents her final score if she gets X questions wrong. What does the y-intercept in the graph represent? Okay, so if we look at this, let's pick a good color. If we look at this, questions wrong. So in the beginning, 0. If she gets 0 questions wrong, okay, in the beginning, that doesn't really fit here, but if she gets 0 questions wrong, that means her score is going to be 180, right? If she gets 1 question wrong, that means her score is going to be 176, right? 2 questions wrong, her score is going to be 172. So what does the y-intercept in the graph represent? Well, the only one that is, let's get rid of all that. The only one, see this is the y-axis, the only point that's at the y-axis is this 180. And that represents what her score would be if she got 0 wrong. So her score with 0 problems wrong. And I think we've done problems like this before, so we should be pretty good at those. Okay, the next type is this, where we're going to have to fill some numbers in a box. Hannah's been given a box of assorted chocolates for her birthday. Each night, Hannah treated herself to some chocolates. There are originally 24 chocolates in the box, and I am going to pause this. Okay, so I could have sworn I've made this video before, but I couldn't find it, so I paused to look for it. All right, Hannah was given a box of assorted chocolates for her birthday. Each night, Hannah treated herself to some chocolates. There are originally 24 chocolates in the box, and Hannah ate 3 chocolates each night. So in the beginning, there were 24, so we put 24 in this box. And each night, she only eats 3. I have no idea if I had a box of chocolates, they'd be gone in that first night, but Hannah can only eats 3 at a time. So if she eats 3, then there's 21 left, right? And then the next night, the second night, she eats 3 more, so those are 18, right? And the next night she eats 3 more, and there's 15. And so then it says, made a table of values, so we did that, check. Then write an equation for c in terms of t. So normally we used to do y and x, but it's okay, we can use c and t. So they already wrote down the c equals. Now we have to know the slope. So the slope, the rate of change, is not 3, it's actually -3 because she takes 3, right? 3 are gone. So we're going to have the -3, and instead of writing an x, we're going to write a t. And then the y-intercept, in the beginning, how many did she have? Well, in the beginning, she had 24. So our y-intercept is 24, and then we'll hit submit, and we'll get that right. Okay, so let's move forward. The third type, we have after baby's born, she begins to gain weight at a rate of 1.5 pounds per month. We know when we see per, we're talking about that is our rate, right? That is our slope, our rate of change, 1.5. The weight of the baby at birth, you can't get any more at the beginning than at birth, was 10 pounds. This is a big baby. So our in the beginning is our y-intercept, that's 10 pounds. Write an equation for W in terms of T. So once again, we're used to X and Y, but that's okay. Instead of saying Y equals, they're saying W equals. They took care of that. So we just need to put our slope in first, our rate of change of 1.5. And instead of writing X, we need to write a T. And then we need to put our Y-intercept, which is 10. Hit submit, and we'll get it right. Okay, so then the last type of question had a lot of words and a big graph, but we can do it. We've got high school A, and we've got high school B. So in the beginning, high school A has 900 students. So that means they start right here in the beginning. And they grow by 50 students each year. All right, so A is going to, let's just write the little thing. They've got 900 students. They're going to grow by 50 students. Does it say use T for years? All right, plus 900. All right, so each year they grow 50 more students. And then high school B has 500. You know what, let's just switch the color here. High school B has 500 in the beginning, so I'll put the 500. And we'll put that it grows, oh, what does it grow? Grow by 100 students. So this one started less, but man, it's going to grow faster, isn't it? And so it says let AA represent the number of students in high school A in T years and BB. Like, oh, there's just too many words. You know what? Let's go ahead and cut to the chase. It says determine how many students would be in each high school in the year they are projected to have the same number of students. Okay. So let's go ahead and graph the purple first because that's going to be easier. We start at 500. Each year we grow 100. So that's up 100 over 1, up 100 over 1. Now on Delta Math, it's way easier to graph because, right, we got that little clicky thing. But anyways, here I'm going up over, up over, up over, up over. Okay. So when we put that little line in, we're trying to connect all those dots. All right, so now we're trying to see where does the green one intersect the purple one. Now, this is a pain because they grow 50 kids per year. So instead of going up, you know what, I'll go up 50. It's half the way, right, half the way over, half the way over, half the way over, over, almost there, half the way over, half the way over, half the way over, half the way over. So this right here is where they intersected, and that, let's get a different color going, that happens at 8 years. So it says, determine how many students would be in the year. So in 8 years, okay, I don't know what else it asked us, but in 8 years, they're both going to have 1,300. So we put 1,300 in and call it a day. So that's very manageable. I think that's the last one. Yep. That's all you're going to see on your writing equations context part of the test. So please ask me if you have any questions, and thanks for joining me.